Hello, in this video we will build a simple library management API together. By the end of this video, you will be able to implement your own web APIs using .NET Core Framework. If you're ready, let's dive in. Let's start off by creating our project. I'm using Visual Studio for my .NET Core projects, but you can use any text editor or IDE you want. For this project, I select Web API. I give a name to my project here, then I click on Next. Okay, our project has been successfully generated. From this part on, I will show you the completed project so that I don't waste your time. I will be explaining every single detail that you need to know. And as always, you can find the source code in the description. Okay, let's start. Let's start with the models. Models are quite important in terms of convenience. If we generate our models, the database operations will be much easier. After generating our models, we can generate the necessary tables on the database without writing any SQL commands. For the sake of simplicity, we will only have 3 models in this project. These models are book, member, and loan, which are the fundamental elements of a library. Let's start with the book model. This model has 4 attributes: ID, title, author, and book availability. The attribute loans is not shown as a column in the book table in the database. It just determines the one-to-many relationship. The ID attribute is automatically generated as UUID, which is universally unique identifier, and the availability attribute is true by default. Here we have the loan model. The model has 4 attributes: ID, the loan date, the return date, and if the loan was extended. Book and the member attributes you see on the screen are just navigation properties. The associated book and member with loans can be accessed using these properties. And finally, our last model is the member model. This model has 5 attributes: ID, name, email, password, and role. The loans attribute is therefore one-to-many relationship because a member may have many loans. Okay, now it's time to generate the tables on our database. For this project, I used Microsoft SQL Server because it works perfectly fine with the .NET Core Framework. But before we do that, we need to make some adjustments to our code. First, we need to install the packages you see on the screen. After we install, we simply add our connection string to the app-settings.json file. And finally, we register our database service on the Program.cs file by adding this line. Okay, we have just one step left to generate tables on our database. We generate a library DB file and register our models in this file to convert them into database tables. Then we execute these commands to migrate and update our database. Okay, we executed our commands and you can see that our tables were successfully generated on our database. Our database will be empty initially, and this will make it hard for us to test our API. In order to solve this problem, we will implement a database initializer file. This file will seed the database with fake data when the application is executed if the database is empty. Since we have successfully built our database, we can implement our repositories. In a web API project, we generally have 3 layers: models, repositories, and controllers. We have already discussed the models. Now it's time to prepare our repositories. Repositories are the auxiliary classes that we use for database CRUD operations. They are very convenient and crucial for the project structure. Okay, let's implement a generic repository interface that contains the frequently used functions for database operations. We can add specific functions to the model service classes later. This file includes all basic functions for CRUD operations. The first function is to get all records of a model. The second one is to get a record by its ID. The third one is to add a record to a table. The fourth one is to update an existing record on the database. And the last one is to get the records filtered and paginated. Pagination is very useful if you have a large amount of data. You can return only a specific amount of them in one request. Here is the implementation of the repository interface. We implement the functions that were introduced in the interface one by one here. We use Entity Framework for database operations for convenience. After that, it's time to implement the services. Services are the classes where business logic comes to the scene. We implement specific functions for library management such as returning a book. I categorize each service into modules like books, loans, and members. Each module has one interface and one implementation class. Okay, let's start with the interface of the book service. In this interface, we have 6 functions: get all books, get a book by ID, add a book, update a book, delete a book, and finally searching for a book. Let's implement the functions one by one. But first things first, we need to have an instance of repository interface that we have implemented before. Since it is generic, we need to specify its type. In this case, the type is book. We also generate a constructor right before the functions. Our first function retrieves all the book records from the database. We simply call the function that we implemented in the repository class. The next function is similar to the previous one, but it needs an ID parameter. The update book function accepts 2 parameters: book object from the user and existing book record from the database. We check if a user has provided the model attributes. We only update the provided ones by simply calling the function we have implemented in the repository class. The delete book function only needs the ID of the book. Then it finds the book by its ID and calls the delete function. In the search book function, we may provide the title and the author that we want to search for. Page and page size parameters are for pagination. We call the necessary function from the repository class. We generate a query with the provided information and pass it to the called function. Now let's look at the loan service interface, which defines the operations for managing loans in our library system. getUserLoans method retrieves all loans for a specific user asynchronously. ExtendLoan method extends a loan's return date by a given number of days, returning success status and the updated loan. ReturnLoan method marks a loan as returned and indicates success with a Boolean value. LoanBook method asynchronously loans a book to a member identified by their IDs. This interface ensures a clear structure for implementing loan management. Next, we'll dive into the implementation of these methods. First, we use the loan repository for general-purpose database operations and LibraryDB context for complex and specific database operations. We generate a constructor using the loan repository and the LibraryDB context. Let's start with the first function of the service. It is used to extend a loan. It accepts 2 parameters: the ID of the loan and the number of days to extend. The function returns a tuple consisting of a Boolean value of success and the instance of the loan object. If the record does not exist or the loan has already been extended before, we just return a false and an empty loan object. If the record exists, we just add the provided dates to the current return date and change its isExtended attribute to true. Then we update the record. The next function is used to retrieve the loans of a user. The function accepts the ID of a user and returns a list of loans. We use LibraryDB context here to retrieve the values using Entity Framework. The LoanBook function is used to loan a book from the library. The function accepts 2 parameters: the ID of the book and the ID of a member. First, we get the book and the member records using their IDs. Then we change the availability of the book to false since it will be no longer available until the user returns it. After that, we add a new record on the loans table using Entity Framework. And finally, we save the changes we've made. The returnLoan function is used when a user returns the borrowed book. It takes the ID of the loan as a parameter. It returns a Boolean value. First, we retrieve the loan record using its ID. We also include the associated book with the loan explicitly because the Entity Framework uses lazy loading of the related data. After that, we change the availability of the book to true because it has been returned. Then we update the database. Now we will look at our last services interface, member service. In this interface, we have functions for getting all members, getting a specific member, adding a member, updating a member, and deleting a member. In the next part, we will implement this interface together. Okay, let's implement the member service. First things first, we generate a constructor using the repository class. Then we can start to implement the functions one by one. Let's start with the adding a member function. The function takes a member object as a parameter. It calls the adding function in the repository class, and we're done with that. The delete function takes one parameter, which is the ID of the user to be deleted. First, we find the user using the ID and then call the delete function from the repository class. The function for retrieving all members simply call the necessary function from the repository class. There's nothing fancy here. Getting a specific member function also does the same thing, but it takes a member ID as a parameter. The function for updating a member takes two parameters, a member object that contains the updated data and the existing member object. First, we check if the existing record exists. Then we check which attributes need to be updated. And we also check if their current values are not the same as the updated ones. For example, if the name attribute was set to David and the current value of the name is also David, we don't consider that an update. For the password part, we hash the password for security because it's a bad practice to store plain text passwords on a database. After all checking, we just call the update function from the repository class. And we're done with that. Now it's time to implement the controllers with these services. Before the controllers, we need to register these services in Program.cs file. We add these lines to register them. We have three controllers: Books controller, Loans controller, and Members controller. Now we will look at them closer. Let's start with the Books controller. In this controller, we will use Books service to perform the functions that we have implemented before. Our first endpoint is for searching for a book. The HTTP method used for this endpoint is get because we retrieve some data from the database. The endpoint has 4 parameters. The parameters are passed in the URL. These parameters are the title, author, page and page size. Page and page size parameters are optional and they are used for pagination. Using our book service, we retrieve the book and then we return the result. Let's see this endpoint in action in Postman. I enter title as U, so it will look for the books containing the word U, and I pass page as 1 and page size as 20, meaning that it will return the first 20 books. I don't pass any author here. As you can see, we have only one book in our database. Its title is You Don't Know JS by Kyle Simpson. Let's also discuss the remaining endpoints. The next endpoint is get all books, which returns all of the books on the database. I have not implemented pagination here, but it's a good practice to implement pagination if there's a huge amount of data to retrieve. Thanks to pagination, you retrieve them piece by piece. Okay, the HTTP method of this endpoint is get for the same reason with the previous endpoint. It returns all the books using the necessary function from the book service. The next endpoint is the same as the previous one but needs a book ID to retrieve a specific book. If the book exists, we return it. If not, we return a not found response. Let's see these two endpoints in action. As you can see, we successfully retrieved all the books from our database. Now, I'm going to use this book's ID to retrieve this book. I changed the ID part here. And yes, we retrieved the book successfully. The addBook endpoint is a post-type endpoint because we add data to the database. The user gives the necessary information about a book in JSON format. Then we add the book to the database. Finally, we return the newly generated book as a response. The update book endpoint is a put type endpoint because we modify the existing data. For this endpoint, we need the ID of the book and the book instance as JSON body. Then we call the necessary functions from our book service. Then we return no content, which means our update is successful. Let's see them in action in Postman. First, we will add a book. We provide the title and author of the book as JSON in the request body. Our book was added. I copy the ID of this book because we will use that ID in the update endpoint. I paste the ID here. Then I change the title of the book. I could also change the author if I wanted to. The response code indicates that our operation was successful. Let's continue with the loans controller. Like always, we import our service and generate a constructor with it. Our first endpoint is getUserLoans, which retrieves the loans of a user. It is a getType endpoint. Our second endpoint is a putType endpoint, and it's used for extending a loan. The endpoint accepts the loan ID and the number of days to be extended as parameters. We use the extendLoan function in our service. If the result is not null, we return an OK response with the book data attached. If not, we just return a bad request response with a message. Let's try these two endpoints on Postman. I provide the user ID to retrieve these users' loans. As you can see, the user has just one loan. Now I use the loan ID to extend the loan for 15 days. We have successfully extended the loan by 15 days. Our third endpoint is a putType endpoint, which is used for returning a loan. It accepts a loan ID. We use the returnLoan function in our service. If the result is successful, we return an OK response with a message. Otherwise, we return a bad request response with a message. Our last endpoint is used to borrow a book. It takes the book ID and the member ID as parameters. Then we use the necessary function on our service. Let's try these two endpoints on Postman. I provide the loan ID here. The loan was successfully returned. Now let's borrow a book. I provided the book ID and the member ID before. The response code is 200, so our request was successful. Let's continue with our last controller, which is the members controller. Our first endpoint is used to get all members. We simply use the necessary function that we have implemented in our service. Our second endpoint is used to get a specific member. The endpoint takes the member ID. We try to retrieve the member. If it exists, we return with an OK response. Otherwise, we return a not found response. Let's try these two endpoints on Postman. Let's get all the members of our library. You can see our members here. Now let's get the member with the ID you see on the screen. And here it is. His name is David and his role is admin. Our third endpoint is used to add a member. First, we hash the password of our member for security using the hashPassword function in our utility class. You can check it out on the source code. Then, using the addMember function in our service, we add the member to our database. And finally, we return the information of newly added member as a response. Our last endpoint is used to modify an existing user. The endpoint takes the member ID and a member object as parameters. Then we call the necessary function from our service to fulfill the request. Finally, we return a no content response, meaning the request was successful. Let's try these two endpoints on Postman. I provide the necessary information to add a new member here. John was added successfully. I realized that I entered his name and password wrong. To modify, I copy his user ID and enter the correct data as JSON. Okay, we have successfully updated the user. Thanks for watching. Don't forget to like the video and subscribe to my channel. See you in the next video.